Good morning, good afternoon, and good evening, wherever you are. I hope you're doing good. What I'm about to cover is a very simple formula for the equation of a circle. Okay, now I'm going to tell you it's probably going to look a little complicated here at first, but as we work through things, I hope that you see that it's really not that complicated here. So, on a piece of paper that you might be taking notes, I'd like you to go ahead and draw this circle out here, and label the points as I've labeled them up there. Now notice that I've labeled them with variables, okay? And these variables can be replaced with any numbers, which is why as I show you this proof, or how this formula is formed, how I'm going to derive the formula, it works in any situation, okay, which is why we're using the variables here. So here's what we're going to do. We have a center of our circle at h comma k, and then I just chose a random point on the circle x, y. Now, I could have chosen any point. I could have chosen a point down here, a point over here, over here. It doesn't matter. What we know is that all of these points on this circle are the same distance from that center, and it's called the radius, okay? So I'm going to use that setup right there to figure out the equation of the circle. Now, how am I going to do that? Well, what we're going to do first is we have to figure out a connection, this relationship, which we already defined as r, but I'm actually going to use the Pythagorean theorem, knowing that all of those points are the radius from the center. Now, in order to figure out this length right here, I know that to get from the origin to this point here, I'm going to go over x and up y. Okay, I get those from those points there. Over x and up y. And I know that to get to this point right here, I'm going to go over h and up k. Okay? So, let me use a different color here. Hopefully this will show up well on your computer screen. If I know that this distance here, okay, is over x, okay, over x up y, and I know that this distance here, from here over to the origin, is going to be over h, then if I take the difference of these two lengths, that's going to give me this length right here. So this is actually x minus h, okay? Now, for the vertical distance there, let's see what that color looks like. I know that this distance here from the x-axis up to this point will be my y value. That length, I don't want to do that part right there. Let's get rid of that. That's going to be a length of y. So I'll put, I'll do it over here so it doesn't get too messy. This length here is going to be a length of y. Okay, so all the way up to this point here. I know that from here up to this point right here is going to be a length of k. All right. So if I take the whole length minus what I have here, what's left over is actually going to be this length right here. So this is actually y minus k. Now, if I plug that into the Pythagorean theorem, the relationship that this point has to any point on the circle is going to look like this. X minus h squared plus y minus k squared is equal to the radius squared. Okay? And that's it. That's the formula. Now, I know it looks pretty complicated. There's lots of parts to it, but it's actually a very, very simple formula. So, if you take a look at the worksheet that I passed out to you guys, let's go to that one next to see how this all plays out. So let me pull that up. Okay, and let's go ahead and fill this in. We know that the center of the circle is going to be at hk, and that we have x minus h squared, y minus k squared is equal to the radius squared. Okay, so with that in mind, let's actually go down to this first example, and let's see how it all works out. Well, we have, I'm going to put h here, k here, so it will look like this. x minus 0, that's the h, squared plus y minus k squared, that is 0 as well, is equal to the radius squared. Okay? Now, how I want you to show this to me, I always want you to simplify everything down into its simplest form. Okay? And so as a result, we don't need to put this 0 here. It's understood. We don't have to put this 0 here. It's understood. And then the 7 squared, I want you to go ahead and square that. Okay? This is the equation that I want you to use given this information right there. Okay? Now, I am going to want you to go ahead and graph it. I know how much you guys love graphing circles. Okay? And again, I'm not going to be real particular, but this is how I'd like to see it. I want you to show me at least the center. Okay? I also want you to show me the radius length. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? That's what I'll be looking for as far as graphing the circle. Now, if you guys have a compass, that would be awesome to go ahead and connect them and just go ahead and do that. But if you don't, just a freehand drawing is good enough for me so that I understand you've got your 4 points. Obviously, I'm not an artist there. Just make it as best you can, and that'll be good enough for me. Okay? Go ahead and try the next one. I'd encourage you to pause the computer. I think that you can probably do it faster than I could explain it. So go ahead and do the next one, and then you can kind of fast forward to the very end of me presenting this next one, and hopefully you'll have gotten the right answer. Then try the third one, then try the fourth one, but don't go and do numbers 2, 3, and 4 without looking at what happened in 2 and then looking at what happened in 3, because each one of these happens to have a little bit different dynamic within each of the problems. Okay, so again, I'd encourage you to pause your computer and take a look at that one. All right, so hopefully you've done number 2 already. Here's how you'd want to do it. Again, this is going to be, let me use a different color here. See if you can see the baby blue. H, K, Carolina blue. We have H and K, which is 4 and 3, radius of 8. So I'm going to plug it in my equation. X minus H squared plus Y minus K squared is equal to the radius squared. Okay? Now again, within these first 2 parentheses, there's nothing that I can actually go ahead and simplify. So I'm just going to go ahead and put this down. X minus 4 squared plus Y minus 3 squared is equal to 64. Okay? This is how I'd like you to show me your answer as far as the equation is concerned. Now, graphing it, I'm going to change my color here because it's kind of hard to graph that on top of what I already have. So we have 4, 3, 1, 2, 3, 4, 1, 2, 3, and you can put your point down there. Okay, that's the center, radius of 8. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, went off the graph a little bit. That's okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Something to that effect right there would be good enough for me. I can see the 4 points. I can see your center. Again, if you have that compass, that would be ideal. So. All right, let's, like I said, I'd encourage you to pause your computer if you haven't already done so, and go ahead and give number 3 a shot. Okay. In the meantime, I'll give you a chance to get that done. All right, so I said that each one of these has a little bit different component. This one actually has two different things in it that we haven't already seen. One is we have the negative here for h, and we also have a fraction for the radius length. Now, how this is going to play out, it's going to be this, x minus h, okay, notice the double negative there, plus y minus k is equal to the radius squared. Okay, so the double negative obviously is going to become positive. Okay, and then we have the 1/2 times 1/2. Now, when you take a fraction times another fraction, you have 1 over 4. A little interesting, when we multiply whole numbers, you get a bigger number. When you take half of a half, you get a smaller number, okay? And so we get 1/4 here as the radius squared, okay? So from there, if I'm going to go ahead and graph that, I'm going to do the -3. Don't look at this part, it's always opposite of what it is. So -3, +4. And you may be asking yourself, how in the world am I graphing a fourth? Well, it's just an estimation. Okay, break it into 4s. And my marker here is very hard to do dots. Something to that effect right there is what I'd be looking for. Okay? All right, again, go ahead and pause your computer, see if you can do number 4 for me. Figure out what that equation will look like. All right, so the only real new component here is this square root of 10, and I really hope that you guys were able to do that part correctly. But if I go ahead and work this out, we're looking at x minus h plus y minus k is equal to the square root of 10 squared. Okay? Well, obviously within the equation, this first part here and this part here, you're going to want to do the double negatives become positive. So x plus 2 squared, y plus 5 squared, and then we talked about this just after the new year. When you have a square and a square root, they will cancel each other out. You can also look at it this way. Radical 10 times radical 10, remember, radical 100 basically becomes 10, or just that base number, okay? All right, so this is what I'd like to see as far as your equation is concerned if I was asking for the equation of this circle. Now, from there, if I go ahead and graph this out, -2, -5. Okay, and then let's see here, radius length of the square root of 10. Now, you want to pull out your calculator here and type that into your calculator. Now, we know it's going to be slightly more than 3. If I do that in my calculator here, square root of 10, 3.16227766. So approximately 3.2 or 3 1/5. So I'm going to go ahead and 1, 2, 3, and just a smidge more than that. Okay. 1, 2, 3, just a smidge. 1, 2, 3, a little bit more. 1, 2, 3, a little bit more. Okay. And then you can go ahead and connect those. So looks something like that right there would be fine. Okay. So again, we're taking our information, we're plugging in our equation, and then we're going ahead and graphing it. Okay? All right, now, looking at the back side, let's take a look there. What is the difference from the front side to the back side? Well, on the front side, we were actually given the radius. On the back side, we're not given it, but we are given the center point. So what we're going to do is we can actually use, you can do one of two things. You can use your distance formula, which, here's a hint, guys, it's the exact same formula, okay? If you unsquare the radius squared within the circle equation, you're going to square root both sides, okay? And what does that look like? It's the exact same as the distance formula, okay? So you can use your circle equation. Obviously, this is the center, HK. And this would be your x and your y value, okay? So if I use my circle equation, it is x minus h squared plus y minus k squared, which will equal the radius squared, okay? If I just go ahead and solve for r, now I have the radius length, and I can solve my equation, I can graph it. So if I do this, 3 minus 0 is just 3, so I have 3 squared, which is 9, plus 4 minus 0 is 4, and 4 squared is 16. Okay, hopefully this is starting to look like a familiar triangle to you. 9 plus 16 is 25, and the square root of 25 gives me my radius. Okay. Now, if I want to go ahead and solve for my equation, obviously it's going to be x minus h squared plus y minus k squared, and that will equal the radius squared. Okay. So in the end, if I simplify all this up, here's what I would like to see as the equation for this circle. 25 there. Okay. All right, but again, what was the key I wanted to get across here? I wanted to make sure you understood how to figure out the radius length, okay? So from there, if we go ahead and graph this, the center's at 0, 0, radius of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. I don't know if my circles are getting better or worse. Holy cow. All right, so again, I'd like you to pause your computer and see if you can work through number 6 for me. See if you can figure out what the radius length will be, and then solve for the equation and then graph it. All right, hopefully you were able to get that done. If you want to just fast forward this, you can, but if you're not real confident, you can watch the whole video here of this example. Here's what I'm going to do. Again, plug into my circle equation. X minus h squared plus y minus k squared equals the radius squared. Okay. From there, if I do negative 4 squared, that gives me a positive 16. I have negative 6 plus 4, which gives me negative 2. Negative 2 squared gives me a positive 4. Well, I have 20, and the square root of 20. If I do the square root of 20, I'll write it over here. That gives me 4 times 5, which is going to be 2 radical 5. Okay? All right. So from there, my equation will look something like this. Again, using my center point, not my point on the circle, I'm going to go ahead and do, let's see here, center x minus h squared plus y minus k squared is equal to, that'll be 20 there. I'll just do this right here, okay? Now I do have to simplify this down, so x minus 3 squared plus y plus 4 squared is equal to 20, okay? So if I go ahead and graph my points, 3, negative 4, 1, 2, 3, 1, 2, 3, 4. I get my point there. And then I have, let me think here, 2 radical 5 is my radius. Now again, like the radical 10 on the front side, we need to go ahead and plug in 2 radical 5 into our calculator. We get approximately 4.5 as the radius length. So I'm going to go over 1, 2, 3, 4 and a half. 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 Yep, my circles are definitely getting worse. Anyways, one thing to think about, and I didn't think about this till I got going with number 6. Number 5, if we go to 0.34, 1, 2, 3, 1, 2, 3, 4, okay, that point right there is on our circle. If it's not, we've done something wrong with the radius length, all right? And of course, this is kind of subjective to the accuracy of your circle, okay? So let's see how far off, because this circle down here looks pretty bad. -1, -6. 1, 2, 3, 4, 5. Not too shabby. Not too shabby. All right, so anyways, that's how you're going to do those type of problems there. Now, if we move on to the last problem, a little bit of a challenge problem here. And here's what we have. We have points on the opposite sides of the circle, okay? So if I was to go ahead and graph this point -1, 4, 1, 2, 3, 4, that point right there, and then 6, 2, 1, 2, 3, 4, 5, 6, 1, 2, okay? Those points are on opposite sides of the circle, all right? So if they're on opposite sides of the circle, what is that? That's the diameter of the circle, okay? Now, you can find the midpoint. That will find the center of the circle. And once you have the center of the circle, you can find the radius length. And once you have the radius length, you can get the equation, and you can graph the circle, okay? Now, I want to remind you, well, there's 2 ways to find the midpoint. The midpoint can either be found by doing the average of the x's, so x sub 2 plus x sub 1 over 2, and then y sub 2 plus y sub 1 over 2. And then I'll show you the other way here in just a second. So let's say I go ahead and make this x sub 1, y sub 1, x sub 2, y sub 2. All right, plug it into my equation. So I get this, 6 minus 1 over 2. Maybe I should just plus -1, which is the same thing as 6 minus 1. Okay. And then I have 2 plus 4 over 2. Okay. So the midpoint here is going to be 5 over 2, which is 2.5. And this one would be 6 over 2, which is 3. All right, so let's see about that. 2.5, 1, 2, 3. Okay. It looks like the center, and obviously, you know, if I got a point up in here, I know I did something wrong because these all have to be collinear. They're all on the same line there. Now, the other way to get this point, I do it about half and half. It's actually quicker and in a lot of ways easier if you're good at counting. I know the rise to run of this whole thing is going to be up 2 over 1, 2, 3, 4, 5, 6, 7. So 2 over 7. Now, I'm going to divide both of those lengths by 2. 2 divided by 2 is 1. 7 divided by 2 is 3.5. 1, 2, 3.5. Okay? So again, if you take half of the slope between the 2 points, you have the midpoint as well. So just something else to think about there if you forget your midpoint formula. Now, from there, again, my point here is, that's my center. Center, there we go, okay? And so, yeah, we've got to be thinking that this is H and that this is K. All right? So from there, I need to figure out my radius length. Well, if I plug it into my, I'll use this point here, -1, 4 with my center over there. So it will be something like this. Let's see here, x minus h squared plus y minus k squared equals the radius squared. Okay? So if we do this, we end up with negative 3.5 squared plus 1 squared is equal to radius squared. Okay? And I don't have negative 3.5 squared. Remember, actually, you know what? I should have probably done this, kept this in parentheses. If you guys don't remember, when squaring a negative becomes positive and you plug in that without the parentheses, it's going to show you a negative within your calculator. So don't forget to leave the parentheses around it there. So 3.5 squared, 12.25. Square of 1 is just 1, so we get 13.25 is the radius squared, and the square root of 13.25 is the radius length. But again, we were looking for this right here, actually, for our equation. So our equation will be this, x minus h squared plus y minus k squared is equal to the radius squared. Okay, and so there you go. You've got the equation. Now, to graph this out, I'm going to take the square root of 13.25, and that gives me approximately 3.6. Okay, and so if I go, let's see here, there's a half, 1, 2, 3. Let's see here. Half, 1, 2, 3, and a little more. Okay, so the circle is actually going out a little more. Half, 1, 2, 3, and just a smidge more. Okay. 1, 2, 3.6. 1, 2, 3.6. Okay, and so something to that effect is what I'd be looking for. Okay, again, making sure that my 4 points and my center are dark enough that I can see those. So I hope that this tutorial was clear enough to understand. If you have any questions, come and let me know. I do have some practice problems I'd like you to do online, so make sure you take a look at that. And I will see you tomorrow. Good night.